As part of my recent web browser video series, I made a couple of videos in which I tested the RAM usage of some of the top web browsers out there on PC. Specifically, I tested Chrome, Edge, Firefox, Brave and Opera, and the results were very interesting. Make sure to check them out if you haven't already. But in my second video, a person left a very interesting comment. They talked about their experience of their browser suffering from a pretty significant memory leak. We're talking close to 20 gigabytes of RAM being allocated to just one program. So that definitely caught my attention. I then decided to go back to the first video and try to see if anyone else was experiencing something similar, and I found a few other cases of excessive RAM usage. Not as bad as the first one, but still noticeable. Now, where things got really interesting is with my own personal experience. Believe it or not, just a few days after I saw the comment on the second video, I experienced a memory leak myself on Google Chrome. In this video, we will explore the concept of a memory leak and we will put some of those browsers to the test. We will also look at what might be causing those memory leaks for people. Okay, so first of all, what's a memory leak? I personally wasn't even aware of this concept until fairly recently. Now, a memory leak is a software error where a program incorrectly manages RAM and allocates it continuously without actually freeing that RAM up when it's no longer needed. In my case, the first abnormality I noticed was when I was on YouTube and I was watching videos from a playlist. So basically with playlists, a video finishes and then it moves on to the next one on its own. After a few videos, the tab just straight up crashed and it showed this out of memory error. At that point, I thought it was just a one-time thing, but then it happened again the next day with YouTube as well. But it wasn't until it happened again later with Gmail that I started focusing on this issue. This time, I actually saw the RAM usage increase while it was happening. So if you're using Gmail on Chrome, and depending on your inbox, you can expect it to use up to 450 megabytes of RAM potentially. As I was checking my emails, I noticed that the tab started lagging to the point where it was pretty much unusable. That's when I started having a look at the RAM usage, which had actually gone up to 1.5 gigabytes. But that's not all, because shortly after it went up to 2 gigabytes, then 3 gigabytes, then 4 gigabytes, then 6 gigabytes, then 8 gigabytes, and then finally 8.9 gigabytes. And it was at that point that the tab crashed. Funnily enough, my main PC has 32 gigabytes of RAM and yet I'm somehow getting an out of memory error. What's even funnier is that I bought a laptop with 8 gigabytes of RAM a couple of years ago and I never experienced that problem on that laptop, which had a lot less RAM. But enough about me for now, let's move on to the testing. So how do we go about testing for a memory leak? It's not something you can guarantee, but what you can do is to create a situation where you're using a particular website for an extended period of time. You can then focus on the behavior of the browser as it handles RAM allocation for that website over that extended period of time. Now, reasonable increases to the amount of RAM being used is generally considered fine. So as long as we're not dealing with a suspiciously high amount of RAM, we can pretty much say we're in a safe zone. There would be two important things that we would need to watch out for. The first is any significant spikes in the amount of RAM being used that technically should not occur. The second is the behavior when it comes to managing that allocated RAM. More specifically, as we run the test for an extended period of time and we see more RAM gradually being used, do we observe decreases as well? So is part of the RAM that is being allocated also being deallocated when it's not needed anymore? YouTube is a good website to test not only because it typically uses a significant amount of RAM, but also because it's easy to emulate a long browsing session that is reflective of actual user behavior. And a good way to do this is by creating a large playlist and focusing on high quality videos so that we can trigger greater RAM allocations. We kick things off with Chrome, which started by using around 700 megabytes of RAM, and that number went up the longer the YouTube tab was open and with every subsequent video. That number reached 1.2 gigabytes and 1.3 gigabytes around halfway through the test, and by the end of the test, it went as high as 1.6 gigabytes. Now, the good thing was that even though these numbers reflect an upward trend, they actually fluctuated quite a few times. So for example, even though at some point we got to 1.3 gigabytes, that number went down to 1.2 gigabytes for a bit as well. And what that tells us is that there was likely no memory leak despite the upward trend because Chrome was able to deallocate some of that RAM that it no longer needed at different intervals. Firefox, on the other hand, was really interesting in that it had a pretty rapid increase in RAM usage. So even though it used significantly less RAM than Chrome, the rate at which Firefox was allocating more RAM was much higher than Chrome. Chrome's increases were spread out much more evenly over the duration of the test, whereas Firefox, which started at 450 megabytes of RAM, matched Chrome's starting 700 megabytes barely a few minutes into the very first video. After that, we saw a bunch of increases of around 50 to 100 megabytes with some fluctuations, and Firefox eventually peaked at around 900 megabytes of RAM. Now, Opera basically combined the advantages of both Chrome and Firefox. So what that means is that Opera was able to spread out the increases more evenly over the duration of the test like Chrome did, while using significantly less RAM than Chrome like Firefox did. We started with approximately 550 megabytes of RAM, which increased a few times by 50 to 100 megabytes, eventually reaching 850 megabytes, which is where it peaked. I also noticed a lot of deallocations happening, which is an indication that Opera was managing its RAM usage rather well. So overall, we can't really conclude that there was any memory leak at any point during the test for any of those browsers. The only thing that happened which potentially resembles a memory leak is how quickly Firefox allocated more RAM compared to the other browsers, especially at an early stage in the test. Of course, we didn't see abnormally large amounts of RAM being allocated, so I highly doubt we experienced a memory leak there. But overall, this is pretty encouraging because it tells us that maybe the latest version of these browsers is more optimized, so hopefully things stay that way. But what might cause a memory leak in the first place? Well, the good news is that there is likely nothing wrong with your PC. In fact, your PC is actually fulfilling the requests that it receives for more RAM to be allocated to a particular program, in this case your web browser, which is what would normally happen anyway, like when you open an additional tab. It's just that the issue is that the amount of RAM being allocated is excessive. This brings us to the bad news. Because it's generally unlikely that there is an issue with your physical RAM or your operating system, this implies that there is an issue with the program itself. Now, I say this is bad news because it means that there is technically not much that we as users can do about it, because it's directly tied to the code, which is obviously handled by the developers of the program. This would also explain why you might experience a memory leak after an update, and also why they may no longer occur after a subsequent update, which I'm guessing is what happened in my case. Memory leaks can materialize in many programming languages, including Python, Java, C and C++, as well as JavaScript. If we consider a developer's perspective, memory leaks can be caused by a variety of factors. Some of those are related to the process of garbage collection, which is basically a memory management mechanism that reclaims RAM that is no longer needed by a program that you're currently running. And as a result, that prevents memory leaks and optimizes memory usage. Now, aside from the fact that some programming languages don't have automatic garbage collection, a problem is circular references, which is when multiple objects reference each other, and so that creates a loop. At a later point in time, even though the objects are not being used anymore, they are still referenced by other objects in the cycle, and so this messes with the process of garbage collection. Another problem is when static variables are misused. A static variable is basically a variable that has a lifetime equal to the entire duration of you running a program. So a static variable is going to be relevant from as soon as you start a program until the very last moment before you shut it down. This is the opposite of an automatic variable, which is created when a function is executed and then destroyed when the function ends. When it comes to static variables, memory leaks can occur when there is an excessive use of static variables. Because static variables stay alive for the entire lifetime of the program, any objects that they reference will stay in the memory, even when they're not being used. In such a case, preventing memory leaks would involve explicitly releasing these objects or avoiding the usage of static variables. But what do you think? Do you think that we will get to a point where memory leaks become a thing of the past? Or do you think that they can still happen no matter how low the chance? I'm very curious to hear your thoughts down in the comments. Thank you so much for watching. I really hope you've enjoyed this video. If you have, please like, share and subscribe. And feel free to let me know in the comments if there is anything that you're interested in and want me to make a video about. In the next video, we're going to be reviewing an upcoming Apple product at a scale that we haven't yet seen on this channel. I'm very excited for that, and I think it's going to be very interesting, so make sure to tune in for that. Also, please consider supporting me by donating to my channel through buymeacoffee.com. I'd really appreciate any support as I continue to bring fun and interesting content like this, only if you can, of course. Link down below. This was the Wizard of Tech, and I'll see you in the next video. Take care.